Last time we were working with quadratic equations, and we had learned a method of solving them called completing the square. You guys remember that? We took that term that was linear, we divided its coefficient by 2, and we squared it, added it to both sides, did a little factoring, square rooting, and solving. And we had gotten to the point on problem number 9 where we ended up with this answer at the end, -3 plus or minus the square root of 7. And I mentioned that we were going to look at the quadratic formula, and we're going to do that same problem with the quadratic formula so that you could see that the answers work out the same no matter which method you use. So, does everybody have the quadratic formula written down? Okay, good. Oh, no? All right. Write it on down. Okay, so we have the same problem that we had from problem number 9 above. It's x squared plus 6x plus 2. And we're going to use the quadratic formula now to solve it. And so we're going to take negative b, so that's -6, plus or minus the square root of b squared, so that's 6 squared, minus 4 times a is 1, and c is 2, all over 2 times a is 1. So we've done these problems before. This isn't new material. So let's see how this simplifies. Go ahead and clean up what's underneath the radical for me. What do you get when you clean up 6 squared minus 4 times 1 times 2? What do you have, Michaela? 28's right, yeah. So I have square root of 28. And the denominator is 2. Okay, so radicals. We worked a lot with those back in the second unit, a few weeks ago, in simplifying those. And so what you'll remember is that we factor, and if you factor 28, it becomes 2 times 2 times 7, because 28 is 4 times 7, right? And since there are 2 2's, I can pull one out. So this is -6 plus or minus 2 square root 7 over 2. That's easy to forget, but when you actually simplify with denominators and radicals with the pluses or minuses and things like that, all of the values that are outside of radicals, that are separated with addition and subtraction, all have to be divisible by the same thing. And this one is. They're all divisible by what? 2. So if I divide them all by 2, I would get -3 plus or minus square root 7. Yes, there's 1 in front of the square root of 7. If you want to put it there, fantastic. Yes, there's a 1 in the denominator. It's just not necessary to write it, so this is what we would have if we don't write the unnecessary pieces. And that's the same answer we got on problem 9 last time. Okay? So you're going to have a few that you're going to look at in terms of the quadratic formula, which we've done before. The reason we're revisiting it again is because when we were looking at the quadratic formula before, for the most part, we had looked at values that were positive underneath the radical. At the very, very end, right before our test, we talked about complex numbers, where we did have negatives underneath radicals. And when we merged the idea of quadratic formula with that idea of negatives underneath radicals, we get an item called a discriminant. Okay, so the discriminant is actually just the value that's underneath the radical in the quadratic formula. It's b squared minus 4ac. And the type of number, meaning is it positive, negative, or 0, that the discriminant holds, tells you how many solutions you get and what kind they are. So if the discriminant's positive, we get 2 real solutions. If it's 0, we get 1 real solution. If it's negative, we get no real solutions, but we get 2 complex solutions with i's in them. Okay? And this is a lot for this one to write down, so I'll pause for a little bit to get you a chance to do that. right, are you guys ready for me to switch my screen? Okay. So what we're going to do on this next problem is we're simply going to find the discriminant. It says to compute the value of the discriminant, and using that value, we're going to decide how many real solutions there are. This problem doesn't ask us how many complex there are, okay? It just wants to know how many real solutions there are. So the discriminant is just the b squared minus 4ac part, right? So what is b in this equation? Yep, negative 12. So negative 12 squared minus 4 times a. What's a? Negative 9. And c? Negative 4. Lots of negatives on this one. All right, what's negative 12 squared? And then what is 4 times, well, I'm going to get a negative because there's 3 negatives, right? Negative 4, negative 9, negative 4. I need 4 times 9 times 4. What do we get? It's 144. And of course, that gives me 0. So what does that tell me in terms of numbers of real solutions? I have 1 real solution. Now, just for the sake of understanding the why, take a look over here at the quadratic formula. If you have this piece underneath here becoming 0, then I really don't need the plus or the minus, right? And that's why there's 1 solution, is because that piece that would have given me 2 solutions it's been eliminated, okay? If that value is positive, then I still have the plus or the minus, and I get the 2 solutions, one that's plus and one that's minus. And if the value underneath there's negative, I still have the negative plus in front, and so I have 2 solutions, but then I have i's because I have a negative underneath the radical. So that's why that's happening. All right, so on this one, we're going to solve it with the quadratic formula, and it even tells us to find the complex solutions, which means we're probably going to anticipate there is going to be a negative underneath that radical, okay? So I know you guys know how to do quadratic formula. We've been doing that now for a couple of weeks. So go ahead and find what you would have for the quadratic formula for this. So go through all the steps, and then once you're done and you've found your solutions, or you think that you're finished, you know, simplifying everything, compare with a neighbor and see if you had arrived at the same conclusion. have the first step on the screen. I don't think that's a concern. I think you guys know how to piece those together, but if you have an error and you want to go look in there and see if you've put something in wrong, please do so. All right, what'd you guys simplify underneath the radical to be? What value goes under the radical on this? Negative 15. Does everybody have negative 15? Okay, good. Now 15 itself does not simplify, right? I mean, it's 3 times 5 and I don't have 2 things to pull out. But the fact that there's a negative means I can do what? I can pull out an I. So I'm going to write 3 plus or minus I square root 15 over 6. Now I know that that 3 at the beginning and that 6 in the denominator just like they're aching to be reduced, but you can't. Why not? Anybody know why? Okay, so what's not reducing, Megan? What piece or where? Yeah, these 3 all have to reduce, and they don't all divide by the same thing. The 3 and the 6 did, but not the I part. If it said 3I, we'd have been good to go, but it doesn't. So we are done right here. Those are our 2 solutions. Okay, I have one more problem in this section. It is an application problem. I've only done one as an example. You only have a few in your homework. We'll do more applications for quadratic formulas a little bit later, or quadratic equations, excuse me, a little bit later. But I wanted to show you one example while we're here so you can see how they can be used. So we have a ball. A ball is thrown at a height of 205 feet with an initial velocity of 11 feet per second. The ball's height in feet after t seconds is given by 205 minus 11t minus 16t squared. And the question asks, how long after the ball is thrown does it hit the ground? Okay, so there's a picture in on your homework when it goes along with this, but the picture they actually show is that it's starting out sort of at a height of 205. 205 feet is pretty high, so you can imagine it being thrown sort of off of a building or out of a window or something like that. And anytime you throw something, it goes down, right? I mean, even if you throw it up, eventually it comes back down. Why? What is it that's causing that? It's gravity, right? And for those of you who have done something maybe with physics or whatever in the past, that's where that 16 is coming from, because it doesn't really show up in the question, right, about the gravity. But the 16 has to do with gravity. So we're actually asked how long before it hits the ground. Well, the height when it starts is at 205. And the height when it hits the ground is what? 0. Yeah, don't overthink this. If it's going to hit the ground, it's hitting at the height of 0. It's no more height. Okay? So what we want is we want this equation, h equals 205 minus 11t minus 16t squared. What do we want this equation to equal? 0, right? Yeah, we're looking for where this equation, or the height, equals 0. Now, it's kind of written in an order that we don't normally write our equations in when we're solving them. The order of exponents is sort of backwards. So if that bothers you, feel free to rewrite it. We can write it as negative 16t squared minus 11t plus 205. And we need to solve this. And you have at least 3 methods for doing that. One of them is factoring. Maybe it factors. But those numbers are kind of ugly, so I'm probably not inclined to think that it factors. Another reason I'm not inclined to think that it factors is it's an application problem, right? Application problems don't always have nice whole number solutions. Second method is completing the square. We could complete the square, but again, it's kind of ugly because the numbers are ugly. So the third method is the one that we just did, which is the quadratic equation, right? The quadratic formula, rather. So I'm inclined, even though the numbers are large, to do that one because it's going to be the easiest to work with under our circumstances.
I have a question. When
Yes,
you
ma'am.
put arts equals negative 16t squared, did you just put it in order, like to make it look nicer?
Yeah, I put it in order because I knew we were going to do quadratic equation, and for a lot of people, it's easier to recognize that they are in order A, B, C.
Okay.
So that's why I did it. You don't have to change the order. You can identify them without doing that, for sure. Just whatever you need to see. All right, so let's take a look at the quadratic equation, or quadratic formula. I keep saying the wrong thing. So this is x equals negative b. So what's b in our problem? Negative 11. So this is 11 plus or minus square root of b squared. So that's negative 11 squared minus 4. A is negative 16. Okay, I'm going to run out of space. Hang on. I guess if you want to be real technical about it, I don't have x, I have t. T is my variable. 4 times negative 16 times c, which is 205, right? All over 2 times a, and a is negative 16. So far, so good? Big numbers, big numbers. Somebody simplify underneath the radical for us. What is negative 11 squared minus 4 times negative 16 times 205? How much? Yep. Good. 13,241. The denominator is negative 32, right? All right, so this is an application problem, which means rounding is appropriate. Agreed? Yeah, absolutely appropriate. And in fact, it tells you in the problem that they expect you to round. So what is in your calculator with an approximation the square root of 13,241? We'll put 3 decimals for now, and we'll round to 2 decimals later. I think it's actually going to be 070 because of the way it does it, yeah. Over negative 32. So there are 2 choices, right? One choice in our answers here is that I have 11 minus 115.070 over negative 32. My other choice is that I have 11 plus 115.070 over negative 32. So let's find the values that each of these give us. These are t equals, right? So what is the first one if I take 11 minus 115.07 and divide by negative 32? What will I get? Rounded to 2 decimals. 27, 26, I have 25 written on my paper, so 25. Double check for me, Sarah. Make sure your calculator's not leading us astray. I have 252. I have 25. Okay, no problem. It's okay. Typos happen. 3.25. What's the other one going to give me? Okay. This is a question that has context. So we need to decide if either one of these answers makes sense, if both of them make sense, or if neither of them makes sense. So that's what we have to figure out. So what is t representing in the context of this problem? Time. So tell me about these answers. We're not having negative time. Doesn't work like that, right? No time machines yet, so this one's really not appropriate for the context. 3.25, however, works just fine, and I need units on it, which would be seconds in this problem, right? Yeah. So after 3.25 seconds, the ball will hit the ground. Any questions?